bring us to stagnation. XRPL plugins, these are really exciting. Right now, if you want to add a new feature to the XRP ledger, you may have to make small changes in 10 different places. That's very hard to maintain, it's hard to do, it's hard to be secure, and you have to do it in C++ because C++ is the language. This idea of plugins will mean that you can encapsulate the feature, and it might plug in a couple of different places, but the feature is sort of logically encapsulated. And that will enable people to build modules that will plug into RippleD. They don't have to be in C++, they can be in other languages, and that'll make it easier for people who aren't familiar with C++ to develop these features. It'll also be nice for people developing features for sidechains and so on. If every sidechain has 57,000 patches to the XRP ledger software, it's going to be a mess. So they need to be modular. We'll support Rust, Python, C++, and JavaScript, we hope, just in the beginning. And this will make it easier. Again, building sidechains will be so much easier when you don't have to make changes in a large number of different places. And there's nothing worse than changing software in a large number of different places. Encapsulating all your changes in one place just makes that development so much easier. Being able to say, here's the module that does this thing that we want to do, instead of here's the 70 things you need to change. And of course, if I make 70 changes and someone else makes 70 changes, they may conflict. If I build a module and someone else builds a module, they won't conflict. Huge, huge innovation. Always improving performance and scalability, throughput improvements, reduced memory consumption. This is mostly coming from Ripple, updates to the core ledger. Memory consumption is important, transaction throughput, I/O efficiency, network usage. These kinds of things are extremely important. They make the system much more stable, and they decrease the cost to run a node. But if a cost to run a node is high, then many people won't run their own nodes. That not only drives people out of the ecosystem, but it reduces decentralization, because when you use other people's node, someone else's node, there's someone you're trusting. So we want to keep the cost to run a node low, and we also want to be able to add new features. Let's say we wanted to add hooks to mainnet. If we were right at the limit in terms of memory consumption and storage and I/O, there's no way we could add a feature that sort of takes resources. The AMM takes resources. The NFT feature takes resources. If we're at the limit of what our technology can do, then we can't add features. So these improvements are extremely important. And on the other side is state stability and robustness. This is about not accumulating bugs. Old code is going to break, new code is going to add bugs sometimes. We can't allow the bugs to sort of increase. So we fixed some node size estimation issues, an issue with subtotaling and gateway balances. We added the network ID field to prevent replay attacks. And we modernized the API to make it a little harder to shoot yourself in the foot, like not accepting the seed and the public key. Updates for newer compilers like Clang 16, fixes and markers, and other bug fixes. I know these are not as sexy as new features, but this is extremely important, because if your code gets buggier and buggier and buggier, eventually it's going to fail catastrophically. Like, you can't accumulate technical debt.